In today's experiment, we have another fun reaction to try, and this is the synthesis of Tylenol, or acetaminophen is really the name of the product. I'm going to start from para-aminophenol here, so also known as 4-aminophenol. And all we need to do is we just need to acetylate or add an acetyl group to the nitrogen here. So we're just making an amide. This is really what this experiment is all about, is making amide bonds. We're making an amide by reacting an amine, it's an aromatic amine here in this case, with an anhydride to produce an amide bond. Now, the mechanism for this reaction is really fairly simple. I have my lone pair on nitrogen here, and my nitrogen is certainly more basic than the oxygen, so it's the more reactive species here. This comes and attacks the carbonyl of the anhydride here to initially form a tetrahedral intermediate. So this will go to form a tetrahedral intermediate. Here, nitrogen, I've got two hydrogens that are attached, then to the carbonyl carbon, O-, methyl group, and the other oxygen here. At this point, I kind of have a couple things that can go on. My nitrogen is positively charged. My sodium acetate that I've got in solution can facilitate proton transfers here. So I could shuttle this hydrogen essentially over to this oxygen at this point just by having sodium acetate come in and kind of pluck that hydrogen off to kind of erase that there for a moment. That will then get you to acetic acid, which this could then pick up that proton to get you to regenerate your sodium acetate and kind of move that hydrogen over to the this fragment here, which would then put a positive charge on that, make that a very good leaving group. And so the tetrahedral intermediate swings down, kicks off that group, that acetic acid group, and this gets us then directly to our acetaminophen product here. So acetaminophen, our Tylenol there. And so the mechanism for this is really straightforward. And this reaction as a whole looks really straightforward. What we may see in lab is something a little bit more complicated. We're going to see right from the beginning that my starting material, that 4-aminophenol, is not a nice white solid, which is what we would like it to be. We generally want to start with really nice, pristine materials. And we'll see that the 4-aminophenol just doesn't behave that way, and so it's not a nice white solid. And we might find that our reaction is kind of plagued by these problems as we go along. So in a very real situation, we may or may not come out with a product that we would want to ingest at the end of the day. Regardless, let's go get our PPE on and see what we get. Here we are in lab, ready to set up the synthesis of Tylenol. Now, we're going to start the synthesis using 4-aminophenol, also known as p-aminophenol or para-aminophenol. And we want to take that and acetylate it using acetic anhydride to produce the desired Tylenol, or acetaminophen. The problem is that if I look at my p-aminophenol, it's not a nice white solid like you would expect for kind of an organic chemical. Most of them are white solids unless it's highly conjugated, which this is not. It's not a nice white solid. It doesn't look at all like something we would want to ingest. In fact, I've weighed out a little bit of it, and I'll show you real quickly. It looks just like charcoal. It's black. Not something you're going to want to ingest, and certainly we wouldn't want our final product to be that black color. Well, the reason that it's black is because 4-aminophenol is very electron rich because of the hydroxyl and amino groups, and it tends to react with itself to form polymeric impurities that are highly colored. So the first thing we have to do in this reaction is we need to remove those colored polymeric impurities. And to do that, what we'll do is we'll weigh out 2.5 grams of our 4-aminophenol, We'll dissolve this in water. Now, the 4-aminophenol is not soluble in water, but we're going to add concentrated hydrochloric acid to protonate the amine and make it water soluble. That will then will dissolve all of that 4-aminophenol. Now it's the protonated anilinium salt, technically, or the aminium salt. That will be dissolved in water. And then we'll add a high surface area material, in this case, charcoal. So another species that looks just like the species we just had weighed out. But this high surface area material will adsorb a lot of the polymeric materials onto it. And then when we filter, we will remove the charcoal and much of the colored impurities. Now, the final solution will not be clear in any respect. It will still be colored, but hopefully less colored, more clarified relative to the starting material, less completely and utterly black. And then we'll be able to carry that forward and react it with the acetic anhydride. Now, in order for the amine to react, the amine can't be protonated anymore, so we're going to have to weigh out some sodium acetate. We'll make up a solution of this. We'll add that solution in. That sodium acetate will help deprotonate the protonated amine and leave you with back to the 4-aminophenol, and that sodium acetate will also help kind of facilitate proton transfers in the reaction. But then that will leave the amine free to react with the acetic anhydride. So we'll get this started. We'll weigh out our 4-aminophenol here. We'll weigh out 2.5 grams of this, and then we'll proceed with the decolorization process. So now that we've weighed out our 4-aminophenol and put it into this 125 milliliter Erlenmeyer flask, I'll now measure out 35 milliliters of distilled water and add that in, and then 1.5 milliliters of hydrochloric acid. And we'll swirl that together, try to make sure we can get the amine fully dissolved. You'll note the solution definitely is not soluble to begin with, although it is a little bit colored, but there's a lot of solid material here at the bottom and some floating along the top. We'll now measure out our concentrated hydrochloric acid. The solution is going to be very dark. We'll go ahead and swirl this now. Try to see as much as possible what we can get dissolved. We'll sort of swirl this for a while to make sure we get as much as humanly possible dissolved before adding the 500 milligrams of activated charcoal. So we've been swirling this for a while, and something interesting has kind of occurred. Not everything is fully soluble, so if we kind of flip this over and see the bottom here, you can see there's kind of some whitish solid there that is not dissolved here along the bottom. Now, this is both a good thing and a bad thing. On the good side, it's certainly less colored. So you can see some definitely, the black material has dissolved, but this kind of much lighter colored material has not fully. So what we really need, though, is we need everything to dissolve here if we're going to be able to do this well. And so we're going to add a little bit more hydrochloric acid to try to get this white solid to dissolve. We've definitely improved the amount, but not completely gotten all of it to dissolve. So we're going to add, just kind of continue to add hydrochloric acid until we can get all of that solid dissolved. So in total, we added, after the very first initial 1.5 milliliters of HCl, we added about 2 more milliliters of concentrated HCl, which you can now see that we are fully soluble. There's none of that remaining solid around, so now we're good to add the 500 milligrams of activated charcoal and heat this on a hot plate just for a while, about 15 minutes, to get to allow the decolorization process to occur. So here we've got our charcoal. We'll weigh out 500 milligrams of this and add it into our flask containing the solution of 4-aminophenol. We'll now take this to the hood and place this in a hot water bath just to help the decolorization process. We have a hot water bath here in the hood, and we'll place the solution containing the charcoal now into that hot water bath. We just let it sort of sit and swirl on and off for about 15 minutes. While we are waiting for the solution to decolorize, we can now go ahead and prepare our sodium acetate solution. So we'll begin by weighing out 2.5 grams of the sodium acetate. And then we'll measure out 10 milliliters of distilled water and add this to the flask and dissolve up our sodium acetate to make our sodium acetate solution. Now that we've let the solution swirl in the hot water bath here for about 15 minutes, what we're going to do is we're going to filter to remove the solid activated charcoal and leave us with our hopefully somewhat clarified solution. It probably won't be clear, but hopefully it'll be more like kind of a light tea as opposed to the black solution that you see now. To do this filtration, what we'll do is we'll take a funnel here, and I'm going to place this on top of another Erlenmeyer flask that we can filter into. I'm going to take some cotton, nice wad of cotton here. Just going to stuff that down into the filter. Just want to have a good kind of material here that will catch that activated charcoal. And then I'll just bring out my solution here. It's very black, as you can see. And I'm just going to carefully pour this onto the filter. Sort of rinse that with some distilled water. The color of the solution in the funnel itself is not that dark. Now, unfortunately, our filtrate here is quite a dark color. Now, we've hopefully managed to remove some of the impurities. What we're going to do actually is we're going to try to repeat this process. We're going to add more activated charcoal. Here, we're just going to kind of weigh out quite a lot, maybe up to a gram. Just do this one more time, and then see if we improve the situation. If we don't, then we'll just carry this forward and hope that it will work in the reaction. So here you can see I've weighed out about a gram, and in fact it's actually 999 milligrams more of the activated charcoal. I'm going to add this in. Rinse down just a little bit that's on the sides there. Now we'll put this back in the hot water bath for about another 10 to 15 minutes. Just hope to see if we can decolorize that solution a little bit more. So we've let this go for a while. We'll go ahead and do another filtration, see if we're any better. If we're not, we're just going to carry this forward. So this solution is actually much improved relative to the last one. It's still very dark, but not nearly as dark. You can actually see through it a little bit more transparent. This is much more like tea. Certainly we could do this again another time, but I think this is now sufficient to carry forward. So now I'll go ahead and add the sodium acetate solution with some swirling. Just because I used so much HCl earlier, I'm just going to quickly check the pH of the solution using some pH paper. So here I am acidic, but I'm not horribly acidic. Only sitting in like maybe around the 5 range, pH 5, so this should work. I will now add the 2 milliliters of acetic anhydride, and then we'll place this back in the water bath for about 15 minutes for the reaction to occur. We'll do this using 2 deliveries of a micropipette. Now that I've added the acetic anhydride, swirl this up some, place this back in the warm water bath, and let this react for approximately 15 minutes. Now that we've let the reaction stir for at least 10 minutes here in the water bath, in the warm water bath, we're going to remove this and place it directly into an ice bath and try to scrape the sides of the vial to induce crystallization, try to get material to come out of solution here. So we'll go ahead and do that now. Move this out, sort of swirl it and bury it here in the ice bath. And then we'll go ahead and begin to scrape, see if we can get any kind of solid material to come back out of solution. So we've let the sample sit in an ice bath for quite a while now, but we're not really getting any crystals or any precipitate to form. We can kind of see here everything's still clear in solution. So what we need to do now is we need to neutralize the solution. Really, the reason the material is still staying in solution is because some of it's protonated, and because it's protonated and charged, it is then soluble still in the aqueous environment. And so we're going to use, very carefully, some sodium carbonate here to deprotonate that amine product, or the amide product, actually, and result in a material that should precipitate out of solution. Now, we need to be very careful when we do this, because when sodium carbonate acts as a base and gets protonated, it forms carbonic acid, which decomposes to produce CO2. So we'll get a lot of bubbling, but we're essentially going to add in small scoops and stir with a stir rod in between each addition, just to get us to the point until we see precipitate form. We'll do that very carefully. So now notice a few things. First, we're not getting as much bubbling. That's definitely subsided some. And also, the solution is now very chunky. There's a lot of solid precipitate there. Any kind of bubbling we're getting seems no longer to really be foaming. I'm just going to test the pH of that solution one more time. Oh, and there we go. Now it's showing green, which is essentially just in our 7 to 8 range. We have neutralized the solution. We no longer seem to be getting that foaming anymore. We are now set to take this to the vacuum filtration setup and collect this material on a Buchner funnel. You may notice a few white chunks here at the bottom. That looks like undissolved sodium carbonate. So I'm actually just, before I put that onto the filter, I'm just going to add some more distilled water, and I'll rinse the whole system with distilled water. So we'll pull air through this for a while, and then we'll place this in a tared beaker and put it in the oven for an additional time, just to help dry the material before getting a crude mass. Break the material up here to try to increase the surface area so it will dry faster when we put it in the oven. And we're all set to put this in the oven. Acetaminophen is supposed to melt around 169, so we should be safe to put this in the oven. So here we're all set to recrystallize the material, our crude acetaminophen. We've got some near boiling water. What we're going to try to do is use a minimal amount of that boiling or nearly boiling water to dissolve the crude aspirin or acetaminophen, and we'll do this on the hot plate. Now that I've got enough material to cover the bottom of the flask, I'm going to put this on the hot plate along with that hot water. Add some more. Try to get everything dissolved and go to the point where the solution is then clarified. Everything's dissolved. My solution is very dark. Seems to perhaps have more colored impurities even after some of the reaction. My acetaminophen seems to have darkened some. Now I've got this solution boiling. It does appear, although it's very dark, it appears as if all of the solid material has dissolved. So I'm going to take this and remove it from the hot plate, let it cool, and then put it in an ice bath and see if we can get some crystalline material to form. Alright, so it looks like we actually got quite a bit of solid material here, a little bit tough to see, but some right in there along the top, and there's some kind of in the bottom. So let's take this over and collect it by filtration. See what we get.